I'd like to disassemble today this Braun Thermoscan in-ear thermometer. It is a thermometer that is used in hospitals, or you can use it private. It is rather quick because you only stick this part in your ear, and a couple of seconds later you can read the temperature in the display. There is not too much interesting about it. Here the green button is to release this, how do they call it? They call it probe covers. Okay, this is for hygienic reasons, that you don't transfer the germs from one patient's ear to the next. You put this cover on, you take your measure, then you push the button, and normally this is ejected automatically. Oops, but that doesn't work anymore. Well, the more interesting part of this, instead of explaining the function of it, is to just have a look inside and to find the little surprise that is inside. We will see. When I say surprise, I don't mean something extraordinary electronic technology stuff. No, it's just something you usually don't find in any device, because it has, a present in it. So first, the battery cover comes off like this. I have already snipped away the battery connector, which I will use for other projects. Then I have already broken the housing, because I thought that probably the screw here will break, but it was a little bit more stable than I expected. So let's remove that screw. We have here not too much inside. Here is the Pyroelectric Sensor. It's like a 1 pixel thermal camera, some sort of. It measures the infrared emission from the patient, from wherever you're measuring. It is limited to a range from about 30 degrees to 45, maybe a little bit higher. That's what normally you would expect when you're measuring a body temperature. There's more covers, LCD display, one button for setting different modes of measuring. There is a switch inside, which can be set to measure centigrade or Fahrenheit. It is now set to centigrade, but that doesn't make much sense because it is broken anyway. Well, the interesting part is this little switch here. It's a nice little standard switch, as you have it in many audio appliances. And funny thing is, it is not connected to anything. Oops, sorry, I was out of the camera. There is no soldered wires to it, nothing. And it is also not connected to any mechanical device, so it has absolutely no function here. Oops, it's a little bit blurred. So you can see that switch. It is mounted in here, and it does absolutely nothing. So the question is, why did they install that switch? Does it make any sense? Well, besides of giving you a free switch that you can take out anytime without compromising the function of the thermometer, I don't know. Maybe there is another model that actually uses that switch, but if this model doesn't use the switch, so why did they put it in? Well, I don't know. Maybe someone knows it and he may tell me, but I don't think that makes a lot of sense. It's just additional weight, additional cost for nothing. Well, another funny feature here, a design feature. The display, as you can see, faces towards the patient while you're measuring. So you're measuring that way, you wait until it beeps or whatever it does, then you turn it over and you read the temperature. The problem is you also have this switch which needs to be pressed with your index finger like that. So the switch, like the trigger of a gun or something, has to be on this side, and the display too. But look at this, they made a special switch thing that allows the flat cable from the display to pass through this slot here. Oops, maybe we need a little bit more light. This slot here. So if you push the switch, then the force goes down around the corner up here, and then it presses the little switch which is located here. Now, if I had designed this, I would have taken the display to the other side, then so you don't have the trouble with this funny switch construction here. So you just use a simple straight switch. You could also read the display while you're measuring something. So I don't know why these people decided to put the display on this side and not on that side. I don't know. Maybe they love it to do it a little bit complicated. So there is another chip down here. It's black, covered with black plastic stuff. It's a chip on board. So the flat cable here is only glued. Oh, maybe it's even soldered. No, it's just glued to the PCB. It's just a piece of plastic with a little bit copper or whatever conductive inside. Really flappy little thing. Chip directly bonded to the PCB. There is some sort of, well, what could it be? A capacitor? No. Could be a crystal marking 1000, probably 1 megahertz. I don't know. We could measure it, but I'm not so interested in knowing about the clock frequency of that chip. Maybe it's just a couple of kilohertz, which would be enough for this application. We have some rubber grommets that hold the PCB tight inside the casing, and also vibration proof. There is another small chip TC40, looks like a CMOS 40 something. I have to get my, oops, where's my lens? Here. It's a 4051, common device, not really modern. Do we have a date code? I don't know. Let me see. Date code 96. Yeah, well, that's not the newest one. Well, we could disassemble the rest of it. I just need a torque screwdriver. That one is too big. This one is a little bit better. One screw, two screws. Well, there is another switch down here underneath the optic assembly. This registers when I push the how do they call it again? The probe covers. When I push the probe cover eject switch, this is actuated, so the logic knows that the cover has been changed and the unit is ready for the next measurement. If you don't change it, or better if you don't push the button, then the display will tell you that you have to change the protection cover, or it will not measure anything. Well, what do we have here? Torques, even smaller. I probably have to switch to my other tool set. So that one fits. Okay, we have some soldered connections. Whoops. Some plastic mechanics. There is another chip. Okay. A high quality capacitor for some sort of something. Maybe it's critical in timing. So we have another screw, which is even smaller. But that's not a problem. I have smaller torqueses. Torqueses, is that the plural of torques? Maybe. Okay, just a little clamp here. Okay, that's shielding. Just wiggle it around. So there we have something in a can that looks like a transistor, which is most likely not a transistor. Maybe it's more like a photodiode, but normally you have, well, let's see what is inside. It moves. Let's break it. Okay, there is another. Ah, okay, that looks like the little transistor-like. Oops, I have to. Yeah, now a little transistor-like device covered with thermopaste. It's most likely to measure the ambient temperature. And then you have this device with a little black window here, which is the thermo sensor. So, and what chip do we have here? I don't expect something funky. TLC27M and a lot of stuff else. I would guess that's an operational amplifier. Oh, that's funny. The sensor here was directly soldered to that pin of this chip. So the pin is bent upwards towards to the sensor, and it was just directly soldered to that pin. I hope you can see that. That's a very funny design. So they didn't bother about making a correct PCB with 3 holes, so they only made 2 holes for the 3-pin sensor, and 1 pin of the sensor went directly to that chip here. Very funny.